So, what is regression? Regression analysis is a powerful statistical tool that allows you to examine the relationship between two or more variables of interest. There are many types of regression analysis, but at their core, they all examine the influence of one or more independent variables on a dependent variable. The regression equation can be impacted by all types of factors, with some being the trend component, the cyclical component, and the seasonal component. When you look at a representation of data, start by asking yourself, what type of trend appears appropriate? Begin with the simplest model. With this data, we can see that it has a positive trend. As the weeks progress, the units of demand increase. The equation that represents a linear trend is y equals mx plus b, with y as the dependent variable, m as the slope, x as the independent variable, and b as the intercept. Applying this to our example, it will be y equals intercept plus slope times week number. In this case, the only predictor for y, weekly demand, is the week number. Slope and intercept can be calculated with simple commands in Excel. To better assess the linear trend, let's try fitting two regression lines, one using only the first year of the data and one using only the second year of the data. If these two regression lines have the same slope, that would suggest that it is indeed a linear trend overall. If these two slopes are different, however, that would suggest that the trend is not, in fact, a linear trend. We can see by extending the two lines that the red line is growing at a faster rate than the green. There was a faster rate of growth in the first year than the second. Since growth is slowing over time, if we use a linear trend for the following year, it would overpredict the demand. So we consider a nonlinear trend. One way to account for the slowed growth over time is to use the same equation, but replace the predictor of week number with the natural log of the week number. The natural log curve grows at a slower and slower rate over time, so this could be a better representation for our trend. It's still not perfect, as you'll see the same seasonal uptake in demand that isn't accounted for, but generally, this representation is a much closer match for our data. More advanced iterations of regression can take into account these seasonal components.